Ladies and gentlemen, good afternoon. My name is John Osborne. I have the honour to serve as the Dean of the Faculty of Arts and Social Sciences here at Carleton. And on behalf of the faculty, and more specifically on behalf of one of the academic units in the faculty, the Institute of Cognitive Science, it's my great pleasure to welcome you all this afternoon to this very special event, which is the first of a new series of lectures we have at Carleton, the Andrew Brooke Distinguished Lecture Series. At Carleton, we're very proud of the fact that our engagement with the process of critical thinking, critical inquiry, is not something that we believe should stop when we walk out the doors of our classrooms, but indeed it's something that should be pervasive in our university culture. It's one of the messages I try to convey to first-year students is that yes, it's important to go to class, but it's also important to get involved in things that happen outside of your classes. And thus we're very pleased to have in the faculty a very lively, active program of special speakers and events. And this is one of the last of this academic year, but obviously from the numbers today, the fact that I think the website crashed for registrations 4 times within the first couple of hours, obviously a very, very popular event. So I'm very pleased to welcome you all today. And I'll now call upon Professor Raj Singh from the Institute of Cognitive Science to introduce today's speaker. Raj.
Thanks, John. So, on behalf of the Institute of Cognitive Science here at Carleton University, I'd like to welcome you all to today's Andrew Brooke Distinguished Lecture to be delivered by MIT Institute Professor Noam Chomsky. As you can imagine, putting on an event of this magnitude would not be possible without many hands coming together in common cause. In the interest of time, I'm afraid I won't be able to acknowledge all of you by name here today, but please know that all of us at the Institute of Cognitive Science are extremely grateful to you for your efforts. Some of you, however, must be singled out for having made this event possible. In the Faculty of Arts and Social Sciences, our Dean, John Osborne. In the Institute of Cognitive Science, our Director, Joanne Lefebvre. Our Graduate Administrator, Leanne Dubray. Our many, many student volunteers, especially graduate student Francis Jeanson. In the Institute of Interdisciplinary Studies, our faculty colleagues, Bill Skidmore and Rebecca Shine, both of whom you'll see more of later this afternoon in this afternoon's talk. Down across the border, Bev Stahl at MIT. And last but not least, Andrew Brooke. Without Andy's vision and pioneering efforts to develop a cognitive science department here at Carleton, we wouldn't have been able to experience the fascinating series of cognitive science lectures that we've witnessed so far. And today's lecture promises to continue this great tradition. Please join me in thanking these many individuals for their service to our community. Just a few words by way of protocol before I introduce our speaker today. So, Professor Chomsky will speak for about 45 minutes. This will be followed by a 45-minute question and answer discussion session. There will be roving mics, so please raise your hand if you have a question for Professor Chomsky. Now, to help facilitate an orderly discussion, we'd like to ask you to limit yourself to a single short question, no follow-ups, and please make sure that it is a question. The only lecture we want to hear today is the one Noam Chomsky will be delivering. So no lectures, no sermons, just a single short question, please, and we can maximize the number of people who get a chance to speak with our guest. Now, the task of introducing someone that the New York Times has called the world's most important intellectual alive is hard enough as it is. But it becomes even harder when you agree with that assessment, as I do. So how do you find the words to summarize in the span of a few minutes the achievements of someone you hold in such high regard? Somehow you need to find a way to limit your objectives. And I'll limit mine by trying to articulate just 2 of the gifts that I think Professor Chomsky has given us. So first, in his intellectual output, he's delighted and stimulated our minds by showing us ideas that I don't think we would have reached without his help. The world is a messy, chaotic place, and in both of his intellectual lives, one as scientist of language and mind, and the other as a critic of power and the intellectuals that serve it, he has pierced through the noisy surface phenomena of the world and managed to look into the deeper forces that govern it. The rest of us have been fortunate to get a glimpse of these fascinating worlds that Professor Chomsky seems to have direct, privileged access to. I don't know how. The second gift is the seriousness with which he takes his role as a public servant. Someone of his stature with many lifetimes worth of good, honest, and indeed revolutionary work would be justified in living a peaceful, restful life of well-deserved privilege. But Professor Chomsky seems to be incapable of feeling things that come all too easily to people like me: fatigue, frustration, self-absorption. More than anyone I know, Professor Chomsky devotes his time and energy to work with other people. He's constantly corresponding through letters, email, often time-stamped late into the night. I don't think that's healthy. Traveling around the globe, giving talks to audiences like this one, with no obvious benefit to himself, but with many obvious benefits to the rest of us. Ladies and gentlemen, it is a distinct honor and pleasure for me to turn the floor over to Professor Noam Chomsky.
Well, I presume you've seen the title, Language and Cognitive Science Revolutions. Cognitive Science Revolutions is plural, and that was by intention. My own feeling is that the major cognitive science revolution was in the 17th century. More generally, I think there's considerable merit in an observation by famous philosopher and historian of science and philosophy, Albert North Whitehead, who wrote that a brief and sufficiently accurate description of the intellectual life of the European races to the present is that they have been living upon the accumulated capital of ideas provided to them by the genius of the 17th century. Now that includes a lot of physics and so on, but also it includes the foundations of neuroscience and what are now called the cognitive sciences, as well as, to a significant extent, linguistics and, to a large extent, philosophy of language and mind. Now, unfortunately, Whitehead's remark is not accurate for these fields. It could be, and I think it should be, that it should have been that they had been living on that accumulated capital, but they have actually not been, to their detriment, I think. And in some respects, what was beginning to be discovered back in the 17th century has been mostly lost, particularly in such crucial areas as the theory of meaning of natural language. I will come back to that, to a few remarks about that if there's time toward the end. Well, in contemporary usage, the term cognitive science refers to developments since essentially the 1950s, and they have certainly been significant. It's commonly called a cognitive revolution. My own feeling is that it seems to me less revolutionary than often supposed if we take into account earlier, often forgotten achievements. Well, the title of the talk raises a more substantive question. The phrase language and the cognitive revolutions presupposes that language exists. That is, that it exists as an independent object of serious study, and not as just some arbitrary collection of various phenomena and processes, more or less like, say, today's weather. There's no science of today's weather, although there may be of the many factors that enter into it. Well, that language exists in a serious sense, it might seem uncontentious, but it actually is very far from that. A major tendency in the cognitive sciences, probably the dominant one, holds that it does not exist, and sometimes states that forcefully and quite explicitly. It's implicit in much of the other work. Well, it's worth remembering that there's nothing new in that stance. So 50 years ago, it was widely held by the most prominent philosophers and psychologists that language does not exist in any serious sense. It's just a matter of conditioning and some obscure notion of induction and analogy. So for probably the most influential philosopher of the period, W.V. Quine of Harvard, a language is just a fabric of sentences associated with one another and with stimuli by the mechanism of conditioned response, and a quite arbitrary fabric depending on the accidental history of conditioning. And that was a widely held view, even though if you think about it for a minute, it's actually incoherent. Where did the notion sentence come from? How is a sentence different from, say, swimming or catching a ball or any other act that allegedly is the result of association and conditioned response? Well, in professional linguistics, a dominant view 50 years ago and more was that languages can differ without limits, apart from very restricted constraints, like maybe choice of phonetic features, which could be properties of the articulatory apparatus. Incidentally, the same thing was held about biological organisms, that they could vary essentially without limit depending on accidental history of selectional processes. By now that's long gone, but that was the view of the time. A further elaboration of this is that linguistic theory, to the extent that exists at all, was just a kind of a battery of procedures to reduce a body of data, called a corpus, to some organized form in one way or another. And how you do it depends on your particular purposes, but there's nothing real about it. There's no truth of the matter, no serious study. Later versions of the non-existence hypothesis within philosophy were that rules of language can be justifiably postulated only if they are in principle accessible to introspection. A dogma that's largely incoherent in my opinion, but that if we follow it somehow, it excludes virtually everything. There are other variants, among them quite prominently the insistence, again by prominent philosophers and others, that language must be regarded as a socio-political entity of some kind. So it's dependent on things like continuity of empires, colors on maps, literary cultures, national myths, military forces, and so on. But it can't be studied. Nothing that complex can be studied. A corollary in the mid-20th century and since is that there are no real problems to solve in the study of language. If it doesn't exist as a serious topic, can't have any problems. The only problem would be, the only thing to do is accumulation and organization of data, maybe what Wittgenstein called an assembly of particulars. Actually, I was a student in the 1940s, and our view among students was, this is kind of fun, but what happens when we've published the structural analysis of every language? There's only a finite number of them, using the methods of analysis that were promulgated, which were assumed to be more or less settled, apart from some details, and which in principle could be automated. In fact, early 1950s, the early days of computers, it was anticipated that they soon would be automated, so that it would be a mistake to do anything in linguistics except just collect data, and when the computers get big and fast enough, pour it into the computers and grind out the procedures and everything else will come. That's actually a view that was held quite explicitly by leading professionals, and the view was pretty sensible, given the non-existence assumption. Actually, similar views are quite prevalent today, namely that the only real object is a corpus of data, and that by automated analysis, complicated Bayesian statistics and so on, one can derive everything that's relevant about the language. Well, the announced topic, language and other cognitive systems, cognitive revolutions, that not only presupposes the existence of language, but it also presupposes a modular approach to the mind, taking it to be much like the rest of the organism. That is, some complex of subsystems, often informally called organs, with enough internal integrity so that it makes sense to study each in abstraction from the others with which it is integrated and with which it interacts in the life of the organism. So, for example, the visual, immune, digestive, and other organs below the neck, metaphorically speaking, and the various so-called mental organs, language, planning, various structures of memory, organization of action, and so on, whatever the right analysis turns out to be. The neuroscientist Randy Gallistel has observed that the biological norm is modular systems with special, I'm quoting him, with special growth and learning mechanisms in different domains and in different species. And I think that's correct, and I think there's every reason to expect human language to keep to the biological norm in this respect, even more so because there are apparently crucial features of human language that appear to be quite isolated in the biological world. Nothing homologous, in fact, nothing closely analogous. Also, these properties seem to have emerged very recently in evolutionary time, many millions of years after the separation of modern humans from any other surviving species. You might say that there were apparently a lot of hominids, but they're all gone, possibly because humans are such a predatory species. Nobody knows exactly why. Well, my own assumption is that language does exist as a module of the mind and body, mostly the brain, but that the non-existence approach in its contemporary form in the cognitive sciences it's actually raising the right questions, I think, although pursuing them in a manner that's almost guaranteed to fail, at least as failure and success have been understood for centuries in the sciences. Important point that I'll come back to. The study of language, of evolution of language, is quite a hot topic these days. You can see that by just looking at the number of books and articles that pour out with titles like that. It's rather odd in many respects. One reason is why it's odd is that there are many much simpler questions which are scarcely investigated at all because they're regarded as much too hard. So, for example, the evolution of communication in the hundreds of species of bees is plainly a far simpler question, but it's just recognized to be too hard to study. Another reason is that very little is known about cognition, the evolution of cognition generally, and furthermore, it's quite possible that nothing much will ever be known, at least by any methods that are understood at all today. That's a conclusion that's been argued quite forcefully and I think persuasively by a leading evolutionary biologist, Richard Lewontin, in essays that are well known but unfortunately neglected. And a look at the literature, by now quite large literature on evolution of language, reveals that it barely even addresses the topic. Instead, it consists almost entirely of speculations on evolution of communication, which is a totally different matter. I mean, you can use language for communication, you can use other things for communication. Most language use is not for communication. So there's different topics. Also, this literature, if you look at it carefully, it's based quite often on very strange beliefs about evolution. I'll briefly return to some of them. Well, I don't want to kind of leave this hanging up in the air, so let me pick, there happens to be one recent essay which very neatly encapsulates clearly the main assumptions of the contemporary non-existence approach to language and its evolution in a prestigious journal, Science Magazine, journal of the AAAS. So I'll use that as an example, but it's just one illustration of many. Now, this is a review article discussing books on evolution of language by a scholar at the Max Planck Institute, N.J. Enfield. He finds nothing, essentially nothing of value in the books that are reviewed. And the reason, he says, is that they are all lethally tainted by the existence assumption. That is, the belief that there's something to study, the belief that there are rule systems of some kind that determine what's a sentence, form-meaning relations, conditions of language use, and so on. To illustrate the fallacy of the existence approach, the article is accompanied by a photograph of 3 infants, suitably interracial, and apparently noticing one another, if you look at the picture. And the caption reads, "Communication without syntax." The point is to show that rule systems of the kind studied under the existence assumption aren't necessary for communication. Actually, they could have given a picture of 3 bacteria that would have shown the right point just as well. This is both the author and the editors. That's their idea. The title of the article is Without Social Context, with a question mark. The question mark expresses the surprise at the fallacy of the existence approach, because it ignores social context when it seeks to determine the functioning rules that allegedly, say, relate form and meaning, determine conditions of language use, and so on. Well, again, to try to make the matter concrete, let's take an actual example. It's simple enough so we don't need a blackboard. So just take the sentence, "He wondered whether the mechanics fixed the cars," and just consider 2 questions that you could ask about that. The 2 questions are, how many cars did he wonder whether the mechanics fixed? Answer, 3 cars. How many mechanics did he wonder whether fixed the cars? Answer, 3 mechanics. But the trouble is, you can't say that for some reason. You can't ask how many mechanics did he wonder whether fixed the cars. In technical terms, it's called an ECP violation. It doesn't matter what that is. The thought is fine thought, but you have to express it in some kind of paraphrase. There's something about the language design which poses a barrier to communication. You just can't express a simple thought like that. You need a circumlocution, many such examples. Well, to investigate such questions of these, according to, say, the editors of Science and the author of the article, you have to consider the social context of the use of these expressions, the normal use. That's very quickly finished. There is none, so you're done. But it's a mistake to raise the question anyway from this point of view, because the sentences are constructed. They're constructed as an experiment. They're not drawn from a massive corpus of data where you'd never find anything like this. That is, the inquiry proceeds by the methods of the sciences as they've been understood since antiquity, but that's another serious flaw. You're not allowed to do that. The observation about social context is actually uncontroversial with regard to communication. You can't study communication without social context. That's virtual tautology. So, of course, the study of communication takes it into account. But it's also uncontroversial that the study of the mechanisms that we put to use in action, whatever it is, that study typically ignores social context, and quite rightly so. For example, for those of you who know this work, the classic work on the neurophysiology of vision, say Hubel and Wiesel's work, for which they got the Nobel Prize, or work on object recognition and constancy, say Elizabeth Spelke, René Vaillant, and others, or, for example, Shimon Ullman's study of how very minimal stimuli, remarkably minimal, are interpreted as rigid objects in motion, or in fact virtually all of the fundamental work that aims to determine the properties of the modules of cognition at whatever level it's conducted, whether it's neurophysiological, behavioral, perceptual, whatever. It ignores social context totally, just as following the normal methods of the sciences. However, we're instructed that the study of mechanisms used, say, in the examples I mentioned, these ECP examples, or the study of, for example, vowel harmony in Turkish, or of the relative scope of operators, or in fact everything else about language, has to depart from the scientific norm. That's a principle. It cannot follow the methods of the sciences. Well, this kind of critique, which is quite widespread, is in fact accompanied by a novel concept of science that has emerged in the computational cognitive sciences and related areas of linguistics. With this new notion of science, which is all over the literature, an account of some phenomena is taken to be successful to the extent that it approximates unanalyzed data. So, for example, take, say, the study of bee communication. According to this conception, the way it's generally conducted by bee scientists is a serious error. What they do is devise complex experiments, circumstances that never arise in nature. So, for example, having bees, training bees to fly to a flower on an island to check to see if there's an odor trail, things like that, and even more complex ones. But that never occurs in nature, of course. It's actually, according to this conception of science, this new conception, what they ought to be doing is taking a huge number of videotapes of bees swarming and do statistical analysis, achieve greater and greater successes in approximating the videotapes, and getting a tolerably good prediction of what will happen the next time bees swarm. Actually, a much better prediction than bee scientists can give. And actually, there's no reason not to do physics the same way. So don't worry about balls rolling down frictionless planes and other things that can't occur in nature. But what you do is do extensive statistical analysis of videotapes of what's going on outside the window, let's say, leaves flying and so on and so forth, and other natural events. And by elaborate statistical analysis, try to get some approximation to it, and you get a pretty good prediction about what's likely to happen next. Again, a far better prediction than the physics department can give, or would care about for that matter. The major cognitive science journals and general journals like Science regularly publish articles triumphantly listing dramatic failures which are called successes because they accord with this new concept, which is unique in the history of the sciences and very radically restricted, in fact, almost specifically to language. So nobody would suggest it for physics or bee communication or almost anything else because it's so obviously absurd that people would just laugh. In fact, it's not even suggested for systems as close to a language as arithmetical capacity. So you don't study arithmetical capacity by constructing models based on a statistical analysis of masses of observations of what happens when, say, people try to multiply numbers in their heads without external memory. At least I hope nobody does that. Enfield, in the same article, he also puts forth a far-reaching thesis, which is quite standard in the cognitive sciences, and a very clear expression of the non-existence hypothesis. Quote him, he says, language is entirely grounded in a constellation of cognitive capacities that each, taken separately, has other functions as well. And notice that's kind of an updating of the 1950s position that I quoted. Well, that means that language exists only in the sense that there exists such a thing as today's weather, which is also a constellation of many factors that operate independently. For example, these ECP examples that I mentioned. He actually cites a source to justify the conclusion, but if you look at the source, it has essentially no relation to it. And that's not because he's chosen badly, it's because there are none that do any better. But he's correct in saying that this is what most cognitive sciences believe. There's another influential version of the idea that language doesn't exist. It's sort of highly dominant in language acquisition studies. Leading figure is Michael Tomasello. So in a recent handbook of child development, he explains that there aren't any linguistic rules and there's nothing to say about descriptive regularities, say like those ECP examples. Rather, there's nothing at all except a structured inventory of meaningful linguistic constructions, all of them meaningful linguistic symbols that are used in communication. That's his topic, there being no such thing as language. The inventory is structured only in the sense that its elements, words, idioms, sentences like the one I'm now speaking, they're all acquired by processes of pattern finding, schematization, and abstraction that are common to all primates. A few other processes, all left quite obscure. So in other words, these ECP examples that I mentioned, according to this story, are learned just the way a child learns the word horse, or an idiom like how do you do, or say kick the bucket, meaning die, and so on, or this sentence, are all learned exactly the same way. And the child somehow learns that the ECP violation is not usable for communication, even though the thought is fine, although the other expression somehow is. And presumably, expressions could have virtually any other properties in the next language you look at. In fact, the inventory, as in the 1950s versions, is essentially an arbitrary collection of unanalyzed linguistic symbols. And it's also finite, just like a Quine's pattern, apart from some hand waving. Actually, I can think of no rational interpretation for any of this, but it's overwhelmingly dominant in the fields, you might think about it. Enfield also presents a closely related thesis that's also very widely held. I'll quote it. There are well-developed gradualist evolutionary arguments to support the conclusion that there's no such thing as language, except as a complex, arbitrary complex of independent cognitive processes. Again, no relevant sources cited, and none exist. He invokes this gradualist evolutionary thesis in a critique of what he calls the saltationist argument that the transition from finite to infinite to unbounded was not gradualist. That's a strange position, but a standard one. It's a logical truth that the transition was saltationist. No other way to go from finite to unbounded. But saltationist is a dirty word in many circles in the cognitive sciences on the basis of a very curious but widespread misunderstanding of evolutionary biology. It's worth exploring maybe, but I'll put it aside here. It's the idea that everything has to happen in small steps. No evolutionary biologists believe that. So, for example, take one recent book by two prominent evolutionary biologists. They take as the central problem the question, how can small random genetic changes be converted into complex, useful innovations? And they give many examples. One of the leading paleoanthropologists concludes that the innovation that set the stage for language acquisition, that moment of evolution, depended on the phenomenon of emergence, whereby a chance combination of pre-existing elements results in something totally unexpected, a sudden and emergent event, presumably some neural change in some population of the human lineage. Rather minor in genetic terms, it probably had nothing whatever to do with adaptation. Quotes. Now, all of this is saltationism with a vengeance, standard in the actual sciences, but considered like a dirty word in cognitive science. Again, intriguing. Well, the fact is we know very little about evolution of language. Maybe we never will. But there are a few fairly clear conclusions, and they're kind of suggestive. So, for example, there's very good evidence that the language capacity is the same for all human groups, which is kind of surprising if you think about it. So it's apparently a fact that if you take, say, an infant from some remote tribe in the Amazon that hasn't had other human contact for, 20,000 years, and you bring it to, say, Boston, its language will be that of my grandchildren, and conversely. There are individual differences, but there's no known group differences. So it follows that there's been no meaningful evolutionary change with regard to language ever since the time when our common ancestors, who are generally assumed to be quite a small group, maybe even in the hundreds, left Africa roughly about 50,000 years ago. And if you go back, say, 50,000 years before that, there's no evidence in the archaeological record of the existence of language at all. So somewhere in that very narrow window, from an evolutionary point of view, a bare flick of an eye, somewhere in that window, there seems to have been a sudden explosion, and you see it in the archaeological record, a sudden explosion of creative activity, complex social organizations, a symbolic behavior of various kinds, recording of astronomical events, and so on. It's what Jared Diamond called a great leap forward. It's generally assumed and plausibly assumed by paleoanthropologists to be associated with the emergence of language. And then, since that time, there appears to have been no relevant evolutionary change. If you want to double or triple the numbers, nothing much changes. Well, these simple observations, which are reasonably well supported, provide some plausible suggestions about language design. I'll return to them briefly. Well, suppose we now assume that language exists, that is, that this meeting is not a waste of time, and suppose we want to look at language as a normal biological system, some module of the organism. Then the standard questions for any module arise at once, roughly speaking, what, how, and why questions. What are the properties of the acquired system, each one regarded as an internal system of an individual? How are these properties acquired, and why do they have these properties and not some other properties? Well, perhaps the most elementary property of human language is that it consists of a discrete infinity of interpretable expressions. So there's 5-word sentences and 6-word sentences, and no 5.5-word sentence, and it goes on indefinitely like the integers. Now that's kind of unusual. There's nothing like that known in the biological world. So that's one isolated property, I mean, maybe down to the level of DNA. What it means is that each speaker, each child, has somehow internalized a computational process, what's called a generative process, that yields an infinite array of hierarchically structured expressions, and each of these is interpreted, in fact, dually interpreted at what are called interfaces with other systems. Sensory motor interface for externalization, for making it available to others, and the what's called the conceptual intentional interface. That means thought, planning of action, and so on. It's a way of saying that language is sound with meaning, Aristotle's common sense dictum. The unbounded range is a very elementary fact about language that appears to have been barely noticed, if at all, until the 17th century scientific revolution. It was noticed by Galileo, Descartes, and others, and they were quite mystified by it, and it played quite a significant role, especially in Cartesian thought, if you look at it. Well, an approach to language that doesn't at least capture this property can't possibly be taken seriously. For language and any other module, internal system, whether it's the visual system or anything else, its growth and development in the individual involves at least three factors. One factor is external data, which can have a big effect on any system. The second is a genetic endowment that converts, for a cognitive module, converts data to experience and guides the general course of development. And third, principles of broader scope, presumably laws of nature, which are invariably a major factor in evolution and development. It's much better understood now than it was 50 years ago. Well, for language, we can analyze the genetic endowment into a component specific to human language. Standard term for that is universal grammar, UG, and other components of the genetic endowment that somehow are relevant to language development, so other cognitive systems, neurophysiological structures, and so on. It would seem prima facie that UG is critically involved in determining such phenomena as the one that I gave as an example, this ECP example. Though if you look closely, it's likely that third factor principles, general laws of nature, are also crucial for that. But we can explore the role of UG in the very early stages of language development, not with complex examples like that. For example, it's now known that newborn infants instantly and reflexively extract language-relevant data from the famous blooming, buzzing confusion around them. That's no trivial task. No one knows how that's done. And it's human-specific. So the infant's pet kitten or chimpanzee or whatever can't do it. It just gets the data. But somehow an infant picks out of all of this data instantly and reflexively the parts that are somehow language-related. Also, the infant very quickly acquires knowledge of the general, what's called the prosodic system, pitch, stress, rhythm, and so on, which is specific to language. In fact, that even happens prenatally. There's evidence that it's going on in utero. Actually, some of the neural tissues that are specifically dedicated to this have now been identified, and they're also human-specific. Then within a couple of months, that's the same is true of the sound system generally. It all appears to be just dependent on UG, in particular neural structures associated with UG. Some of the early steps may also involve other cognitive processes. So, for example, in my own first work on this topic, back around 60 years ago, I took for granted that extraction of words from running discourse, that's a tricky operation too. The kid is hearing just running discourse. How does it break into words? I assume that this has got to be based on evaluation of transitional probabilities, which go up and down depending on where word boundary is. So it seemed, since there just seemed to be no other relevant evidence. However, the matter turns out to be more complex and much more interesting. Recent work shows that this method fails, although the results very sharply improve when it interacts with UG principles. So, for example, 6-month-old infants segment running text, running discourse into elements with word-like properties when high transition probabilities are aligned with phrasal prosodic constituents. It's a pretty abstract notion, but phrasal prosodic constituents are picked up by the language system, and if they're aligned with sharp rise in transitional probabilities, then you get something like word-like elements out of text. All of this is done by completely unconscious and reflexive processes. Well, although real results remain very sparse, contrary to many claims, the role of statistical reasoning and other cognitive processes in language acquisition, potentially at least, should be a significant area of research. It's something that's never been in doubt since the early origins of current work. There are also presumably conditions imposed on language by the structure of the brain, although so little is known about that you just can't draw any conclusions. There's knowledge about localization, a few other things, but nothing about how it's actually working. In fact, it could be that neuroscientists are looking in the wrong place. Randy Gallistel, again, well-known neurolinguist, he's argued, again, pretty persuasively, that a fundamental reorientation and centuries of the study of the brain are going to be necessary to discover the neural roots of the computational capacities, not only of something like human language, but even of insects, where they're indeed quite astonishing when you look at them. Well, let's turn to UG. The question whether language exists is basically the question whether UG exists. Is there some genetic element that's specific to language? As I mentioned, this is commonly denied, but I simply am unaware of any coherent alternative. In the early work on this topic in the 1950s, it seemed as though UG must be extremely rich to achieve any degree, to allow any degree of descriptive adequacy in dealing with the complexities of language. And one major goal of theoretical linguistics, in my view the major goal since that time, has been to reduce the postulated complexity of UG in accounting for the phenomena of language. The reasons for this pursuit are quite straightforward. One of them is just normal rational inquiry, that is trying to achieve greater explanatory depth. Another reason is the hope that maybe someday there'll be an eventual serious study of evolution of language. Evidently, this task, to the extent that it's feasible at all, is rendered more difficult to the extent that the postulated target, UG, is more complex. Well, actually, the non-existence approach shares the same goal, to reduce UG, actually to reduce to zero in that conception. But there are several salient differences between these two approaches to the question. The first is with regard to results. I can't show it here, but I think it's fair to say that there are virtually no results in the non-existence literature, except in terms of this curious notion of science that has been contrived, departing from the entire history of science, the one I mentioned. In contrast, there are quite substantial results in the existence literature. Overwhelmingly, they result from investigating what I call third factor considerations, considerations of computational complexity. Actually, the inquiry hasn't been phrased in those terms, but that's what it comes down to if you look at it closely. So these steps, for those of you who know what I'm talking about, it won't mean anything to others, but these steps include dissolving constructions into more general components, elimination of phrase structure grammars, which have extremely rich stipulations, a radical reduction of the complexity of transformational grammars. These were designed to accommodate non-contiguous relations, which are ubiquitous phenomena and in displacement and morphological discontinuity. And finally, in more recent years, unification of these two approaches in what appears to be the simplest possible computational operation, one which has to operate in any generative system and seems to accommodate both of these, or so it's hoped. In recent years, the inquiry into these topics is often called the minimalist program, but that term has been extremely misleading. I'm sorry I ever used it. This is just ordinary science, normal, ordinary science, extending the main thrust of theoretical linguistics since the earliest days of contemporary work in the 1950s. And these developments are pretty natural if you think about it. Language is very clearly a computational system, so it makes very good sense to seek the role of general principles of computational efficiency that apply far more broadly and may indeed be rooted in organism-independent natural law. And that's particularly natural, given the little we know about the evolution of language. So go back to that. It appears overwhelmingly clear that a generative process suddenly emerged at some pretty recent point, maybe in that window that I mentioned, Great Leap Forward, right about then. Well, it emerged in an individual. Mutations don't take place in groups. So some individual was fortunate or unfortunate enough to get this generative capacity. Well, that's maybe some slight rewiring of the brain. Furthermore, there was no selectional pressure at that time. I mean, there couldn't be. It's just something that happened to an individual. So what you'd presumably expect what appeared at that point to be just determined by natural law. There's no other pressures, something kind of like a snowflake. And the same would be true as this capacity, or this property is transmitted to offspring. Notice that the capacity itself has selectional advantage. That is, the person who had this capacity could think, could plan, could interpret, could construct internally, of course, complex thoughts. That you'd expect would have advantage transmitted to offspring in some small hunter-gatherer group, maybe a couple hundred people. It could take over most of the group after some period. And at that point, there would be a reason to externalize it, to make it available to others, so it's not just in your own head. And that seems to be the way language works, with externalization being an ancillary process. Well, consider again the what questions. As soon as the question was addressed within the framework, this general framework about 50 years ago, many puzzles came to light which had previously been unnoticed. Actually, some of them are still on the agenda. Actually, that moment is somewhat reminiscent of the very early modern scientific revolution. So for millennia, scientists had been satisfied with traditional answers to such simple questions as why a rock falls to the ground and steam rises to the sky. They're seeking their natural place, Aristotle's answer, so that ends that problem. 17th century scientists were the first ones, actually, to have allowed themselves to be puzzled by that and to investigate it. And they very, very quickly discovered that conventional beliefs were completely false. Well, at that point, science entered a new phase, its modern phase. And the capacity to be puzzled is very well worth cultivating. And that's essentially the Galilean revolution. I don't think it's happened in other fields, but it begins with the capacity to be puzzled about very simple phenomena, not just to say, well, it's natural, so nothing to look at. There were myriad puzzles that emerged as soon as the first efforts were made beyond, to go beyond hand-waving about analogy and training and pattern formation and so on. I'll mention two, at least one, maybe two if there's time, because these are among the very few cases for which answers have been sought, relying on non-linguistic cognitive processes and typically adopting the non-existence assumption. One very hoary example has to do with what's called auxiliary inversion. So take the sentence, can eagles that fly swim? Simple sentence. We understand right away that the question is whether eagles can swim, not whether they can fly. That is, the auxiliary element can is associated with swim, not with fly. That's obvious from the interpretation. It's also obvious from just plain morphology. You can say things like, are eagles that fly swimming, where the R is going with swim, obviously. Have eagles that fly been swimming? You can't, however, say, are eagles that fly swimming? It has a meaning. It means, is it the case that eagles that are flying swim? But you can't say it that way. There's something about the design of language that hampers communication. It compels a paraphrase, much like those ECP examples that I mentioned. There's a perfectly good thought, but you just can't express it, except in some roundabout, complex way, some result of language design. So the thoughts are fine, it's just can't articulate them. Well, this simple question about auxiliary inversion, which is quite trivial, it had never arisen in millennia of careful study of language, because the point was just taken to be obvious, like objects seeking their natural place. But why should it be the case? So take the sentence again. Can eagles that fly swim? Just on the basis of ease of computation, you'd expect that the fronted auxiliary can should be associated with the closest verb. That's the easiest computation, hence with fly, not with swim. Actually, communication would be facilitated if both options were available. And that would avoid the need for complex paraphrase in one case. So if you want to put the matter a little bit differently, there are two concepts of minimal distance that are available. One is minimal linear distance. Just count, get the two things that are closest. That would relate the sentence to eagles that can fly, swim. Can eagles that fly, swim? That's minimal linear distance, wrong result. Minimal structural distance relates the sentence to eagles that fly can swim. Can eagles that fly swim? The right result. The reason is that eagles that fly is a phrase, and you look at the structural distance, can is the closest one if it's near swim. Well, the question then is, why does the language learner reflexively minimize the property of structural distance rather than adopting the computationally far simpler property of linear distance, or for that matter, adopting both of them, which would facilitate communication, as I said? Well, notice that there is a good answer to the what question. Minimal structural distance remains unchallenged, and not only in these constructions, but in plenty of comparable constructions and in every language where such things exist. So it's an answer to the what question. Somehow minimal structural distance is built in. And the question doesn't arise for the child. It's the only choice. And that still leaves the how question and the why question. There's a very simple and quite likely correct answer, and that has to do with the general architecture of the language faculty. So go back to Aristotle's dictum, languages sound with a meaning. Probably the case that that's not quite accurate. A language is not sound with a meaning, but it's meaning with sound. Which is quite different. That means that the core of the language faculty is a generative procedure that yields structured expressions that are interpreted at the thought system, conceptual intentional system, while externalization to the sensory motor system is a secondary process. Well, linear order is clearly required for externalization, but not, it appears, for the core systems of thought, syntax and semantics. It seems then that it's just a reflex of the sensory motor system. And as you would expect, it varies depending on the sensory modality that's used for externalization. So it's somewhat different for sign and speech, say. Well, though it's not uncontroversial and there's empirical issues, there is growing evidence that this is indeed the case. And as I mentioned, it fits very well with the little we know about evolution and what's known about language more generally. I won't go into that, but it's true. It would also follow that communication is an even more peripheral aspect of language than I mentioned before, because communication is contingent on externalization, and that the substantial literature of speculation on language evolution is simply on the wrong track. Well, if that's correct, you immediately get answers to the how and why questions for auxiliary inversion. A linear order is simply not available to the language learner. The language learner is guided by a very simple principle of universal grammar. Look for minimal structural distance, and that's the only one available, because if you don't have linear distance except at some peripheral part of language, then that determines the general architecture of language, and it's computationally quite natural. Well, auxiliary inversion has been the topic of a considerable industry in computational cognitive science. In fact, it's the main topic that's been studied. To try to show that the child acquires this knowledge on the basis of statistical analysis of a corpus of data in accordance with the non-existence thesis. And there are new papers that come out regularly on this, even the past few weeks. They have very curious properties. One is that every one of them fails, and fails dramatically. Second is they're all cited as examples of successes in the literature. And they are examples of successes in terms of this new notion of success, which departs from the entire history of science, more or less matching unanalyzed data. Another curiosity is that they all ignore the simple explanation, which is pretty well conceptually and empirically based, minimal structural distance for the reasons I mentioned. Another reason is it wouldn't matter if these approaches succeeded, although the people carrying them out don't seem to perceive that. If these methods succeeded, it would mean nothing, because if you had a non-language which used linear distance rather than structural distance, the methods would work for that too. But that's not the case. Every language uses structural distance. So even if they worked and they're total failures, it wouldn't mean anything. But that doesn't seem to matter. Kind of a background question that you might think about is, how does the child even know what the intended interpretation is in such a sentence as "cat eagles that fly swim," unless it's already relying on the minimal structural distance principle without any data at all? I was going to talk about some of the cases, but I think it's, I'll skip them, just go into them if you like. But there are one or two other cases that have been extensively discussed in the computational science literature as exactly the same thing. You find the same thing. Total failures, regarded as successes, wouldn't matter if they worked, and it's considered fine. It's a strange thing about cognitive science. Cognitive scientists sort of be interested in thinking about it. I don't want to end without at least mentioning another extremely serious problem, which has been barely addressed. A computational procedure requires certain atoms of computation, something to start with. And for language, that's called a lexicon of minimal elements, maybe roughly word-like, but not exactly. Even the simplest of these elements raise fundamental puzzles, fundamental problems about how they relate to the mind-external world. Well, there are two aspects to the question. One is meaning, the other is sound. The sound aspect is secondary, ancillary, if the reasoning I reviewed earlier proves accurate. For sound, it's been investigated. The answers lie in articulatory and acoustic phonetics. And the problems are hard. They've been studied intensively for 60 years using sophisticated technology. It's given sub-answers, but it leaves many outstanding problems. Well, what about meaning? Now, that hasn't been investigated because of failure to reach the level of a Galilean revolution. There's a standard answer, like objects go to their natural place. The standard answer is provided by what's called referentialist doctrine. So the word cow picks out cows, maybe by some causal relation. Actually, something like that does seem to be true for animal communication. So the symbols in animal communication do appear to relate to physically identifiable external or internal states. So, say, for a vervet monkey, motion of leaves elicits a warning cry, which we interpret as saying an eagle's coming. I don't know how the vervet interprets it. Or say, I'm hungry. It goes back to an internal hormonal state, which is identifiable. Nothing remotely like that is true for even the simplest elements of human language. The cow, river, person, tree, pick any one you want. There are inklings of that understanding in classical philosophy, back to Aristotle, and it was considerably enriched during the first cognitive revolution in the work of British Neoplatonists and classical empiricists. They recognized that there is no direct link between the elementary elements of language and thought and some mind-dependent external entity. There's just no link. There's no relation of reference in human language and thought. Though there is an act of referring, that's a very different matter. Rather, these minimal elements, like these elementary words, they provide rich perspectives for interpreting the mind-independent world. 17th century, they were essentially studied what we call, they didn't call them this, Gestalt properties, cause and effect, sympathy of parts, concerns directed to a common end, psychic continuity, and other mentally imposed properties, properties that the mind imposes on the world. A physicist can't find them. Similarly, in this respect, meaning is rather similar to sound. So, for example, every act of articulating some item, say articulating the internal syllable ta, let's say, every act of articulating it yields a physical event, but no one seeks some category of physical events associated with ta. There isn't any. Similarly, some, but by no means all, utterances, uses of the word cow or river or whatever you like, some of them refer to physically identifiable entities, but there's no category of such entities that's identifiable in principle by a physicist investigating the mind-external world. David Hume had a simple phrase summarizing a century of inquiry into this. He said that the identity that we ascribe to vegetables, animal bodies, artifacts, persons, and their minds, the array of individuating properties, is a fictitious one, established by what were called then our cognoscitive powers, our cognitive powers, we would call now. Well, most of this has been forgotten, unfortunately, but there's quite strong evidence that it's basically correct. And once again, failure to be puzzled by these things is a very serious error. It seems that these elements, so fundamental to human language and thought, reveal another vast chasm between humans and other animals. And they pose a huge problem for evolutionary biology and a comparably huge problem for acquisition of language. It's called what's sometimes called a poverty of stimulus problem, similar to those I mentioned. Now, there's interesting experimental evidence that a child acquires these words, say a word like cow, on a single exposure. That means on a single exposure to the word cow in some situation, the child conjectures what it means. And that's almost invariably right. Confirming evidence doesn't seem to have any effect. I mean, disconfirming evidence would have some effect, then maybe we would abandon it and pick up something else. But it seems to be one trial learning. In other words, no learning at all. It just something clicks, and you get the association with the meaning. Of course, the sound symbol association is acquired, but the meaning is not acquired. That's somehow coming from the inside without any direct evidence, much as in the other cases I discussed. And that, which, if you investigate the meaning of these words, it turns out what's coming from the inside is quite rich. The what, how, and why questions raised by these systems have only barely been explored because just of the unwillingness to be puzzled, despite their fundamental significance for thought and action. the origin of these basic elements and their organization, now that remains entirely unknown. And if Richard Lewontin is correct, they may remain a permanent mystery for human inquiry, but they certainly will be if they're not even investigated. So in this domain, a basic one, we really are in the pre-Galilean stage. Okay, I'll stop there.
Those are the roving mic people.
I wonder, Mr. Chomsky, if you might briefly discuss the difference between literal interpretation. I'm over here to your left. Hi there. If you might briefly discuss the difference between interpreting language literally and figuratively or ironically, that sometimes we tend to take a singular interpretation versus multiple meanings from any given snippet of text.
That's certainly true. I mean, these are all very important complexities, but what's striking is we don't even begin to understand the simplest cases. I mean, let's go back to Galileo and motion. I mean, Galileo didn't try to figure out how leaves fall. I mean, it's true, leaves fall too, but, that's so overwhelmingly complex that, in fact, modern physicists don't even try to study it. First, you want to see if you can find whatever works for the simplest cases, and maybe on the basis of that, you can extend to other cases. And I think that's true here, too. So, yeah, these are important questions. Doesn't mean they shouldn't be investigated. You can learn things about them, but one should recognize that we're not going to understand much about them if we can't even understand how a child comes to grasp the concept cow or person or tree or river or anything else. And we're very far from that.
One of the questions or one of the things you argued in support of language is productivity, and Fodor uses the same argument for a language of thought. I wondered if you think language plays a greater role like Fodor does, and maybe is there such a thing as a universal grammar of thought?
Well, I do think so, and in fact, what I was describing was a language of thought. So, I mean, I think what actually seems to have happened, as far as we can piece anything together, and as far as the empirical evidence shows, is that at some point, say maybe 75,000 years ago, some small neural rewiring took place, of course, in some individual, because it's the only possibility. And that individual had a computational process which was somehow linked to pre-existing conceptual structures. Now, what those pre-existing conceptual structures are, we haven't a clue about that. That's the problem I ended with. Nobody has even a clue what that could be or where it could have come from. But it's there, and it's totally different from anything in the animal world. And if this generative procedure could link to it, you do have thoughts. So that's a language of thought. And then somewhere down the line, got externalized, and you get interactions among individuals. So yeah, I think it is a language of thought, but I don't see any reason to think it's separate from language. I think it just is language. In fact, if you look at Fodor's work, and you ask the question, well, what do we know about the language of thought? Well, it turns out to be English. What?
We think everybody in English. You are saying that we think everybody in English.
I'm not saying we think in English, but the reason it turns out to be English, that's the language everybody's using. But probably, whatever the language of thought, this our own internal language, yours and mine, whatever it is inaccessible to introspection. Okay, I mean, if you introspect, you can't go 1 minute without talking to yourself. It takes a tremendous act of will not to talk to yourself. In fact, you do it all night. It keeps you up all night. But it's just impossible not to do it. But what you're introspecting is the externalized language. So you can tell when you're talking to yourself, you can tell whether two sentences rhyme, let's say. Okay, or you can tell how many, how long they are, or something like that. And actually, if you really pay attention, you're not really introspecting, you're not really talking to yourself in sentences. It's kind of odd little fragments. Something is going on deeper, which we can't introspect into any more than you can introspect into the mechanism of vision, and that's the language of thought. And it's probably universal. It's hard to imagine how it could be anything else. There's no evidence for acquiring it.
Thank you very
Incidentally,
much.
an interesting question which has never been investigated, I've been talking to some of the researchers on it, is about sign. It's been learned in the last 20, 30 years that what's called sign language is almost identical to spoken language. Same mode of acquisition, the same neural representation. I mean, everything you look at is the same. It's just a different modality. So what do signers, how do they introspect? How do they talk to themselves? Well, the guess of most researchers is, well, they probably sign to themselves. But we don't know, It's an interesting topic.
Thank you very much for your talk, Mr. Chomsky. I had a question about artificial intelligence, robots, and to your left, where actually he's standing. Yeah. So it's sort of, do you think, despite the complications and the lack of knowledge we have, that we will develop some sort of machine language capability which is A, functionally equivalent to our own, or B, similar to our own in the next 10, 20, 50, 100 years, ever?
So I didn't get to
So will we develop a functionally equivalent machine in the next 10, 20, 50 years?
That will we? It's hard to know what that means, actually. I mean, we're a machine, okay? I mean, we're not made out of ectoplasm. So we're some kind of biological system, which means that, at least in principle, somebody could construct that system. You could ask that question about the visual system. Can you construct a mammalian visual system? Well, everyone assumes probably you can, but that question is the same as the question, can we understand what the visual system is? And I think it's the same with language. To the extent that you understand what the system is, you can, at least in principle, duplicate it in some other, physical modality, mechanism. But it doesn't tell you anything. And in fact, we can't get very far in it because so little is understood. Look, what I was talking about is artificial intelligence. It's not called that, but this is artificial intelligence, trying to figure out what the mechanisms are that enter into one capacity of intelligent behavior. That's what presumably artificial intelligence is. What people usually mean by artificial intelligence is, a little robot that does amusing things. Well, okay, that's actually there was a famous debate. This is kind of unfair, but there was a famous debate at MIT long before your day, back around 1960, I guess, between Marv Minsky, who's the kind of guru of artificial intelligence, and Jerry Letvin, who was a very smart biologist. And in the course of the debate, Jerry famously said he thought it was a great topic, artificial intelligence, but he thought it was misnamed. It should be called natural stupidity. A little unfair, but...
Can you all please stand when you ask your questions, please?
Dr. Chomsky, I was wondering, when you were speaking about the evolutionary biology part of the question, i.e., what moment in time when a member of the species developed the capacity to have language, first of all, without a written language, what kind of evidence can you find in the archaeological record? And secondly, is it not possible that at the moment when the primate that is us developed language, we became a new species entirely, such that language is such an integral part of Homo sapiens that you can't really distinguish between people without language and people that have language?
Well, as to becoming a new species, that's a matter of definition. If some rewiring took place, then it's in a sense a new species. You know, how much change has to take place to call it a new species? There's no answer to that. So yes, it was a different creature in a minimal sense. The reason what you were just saying is kind of similar to Richard Lewontin's argument. He says by the kind of inquiry that anyone knows how to carry out, we're never going to find out anything about this. Not only is there no written language, there's no tape recordings, you know, there's no direct evidence of what must have happened. But then that's true of paleoanthropology altogether. All you have is artifacts, and you don't even have soft tissue, because that degenerates. What you have is, you know, skulls, hard tissue, and you have artifacts, like tools, you know, drawings, recordings of which you can pretty well determine are recordings of natural events. Well, it turns out that if you look at the paleoanthropological literature, there's good summaries of this, like by Ian Tattersall, for example, one of the main scientists. It turns out that roughly in the window that I mentioned, you know, you can't give a date to it, but say 75,000 years ago, plus or minus a couple of tens of thousands, doesn't matter. You do get what this so-called great leap forward. All of a sudden, there's an explosion of complex artifacts which reveal a lot of creativity. If you compare humans with Neanderthals, you know, that's the closest living, almost living relative up till 30,000 years ago. They were all over the world. They were very successful, biologically successful organism all over the place. They have very sophisticated abilities. Like Neanderthal could make tools so refined that modern humans can't make them except with instruments. But they were all the same. You know, you go to Asia, you know, Europe, Africa, wherever they are, it's always the same tool. And there's no indication of any creativity. You know, it's a little exaggerated, but overwhelmingly, there's essentially no creativity. And that's the record of human origin, you know, early human origins too. Complicated tools, but they're made in a particular way 1 million years ago, and then they're made in a different way 200,000 years ago, but there aren't signs of major change. The big change seems to be roughly in this window, and it's indirect evidence. It's coming from artifacts. There is some evidence about brain size. It appears to be the case that you can tell from the skulls that the brain did undergo some big increase around 100,000 years ago. And it's been speculated that whatever that brain increase was, whatever, nobody knows why it happened, but whatever it was, it allowed for changes in the internal structure of the brain, which we know almost nothing about, incidentally, that permitted this development to take place. I mean, it's indirect evidence. You know, it's kind of like cosmology. You're not there. You have to reconstruct from indirect evidence. But that doesn't mean you can do nothing, you know.
Hi. I was wondering, because you were talking about how in science they had a complete rework of everything they had thought of. Maybe in linguistics, one of the things that you have to think of is you put forth the idea of language existing and not existing. Perhaps those are two totally different entities. So maybe one language, the one that exists, is something like math, so it's a formal language, and then you have an informal or natural language that's kind of jury-rigged together in the same way that like biological organisms are, where not everything works properly, and that's why you get these confusions within language.
Yeah, so you're asking about formal languages?
Well, I mean, is it possible that non-existent language and existent language, like language exists and doesn't exist at the same time? So the two different notions that you were talking about are both correct, but they both refer to two different things.
I don't know what that would mean. I mean, there's a biological question. Is there a genetic component to what you and I are doing?
No, like what I mean is, so you're saying that you can look at language, like when you have these problems when you use syntax and semantics and stuff, that you can't get what the person is talking about, or you're missing data because of the way that the sentence is constructed. And then...
Well, I'm still not understanding. I mean, there is a straight scientific question. You and I are doing something, okay? Yeah. Does that trace back to some genetic factor that's common to you and me and every other member of the species and is non-existent in any other species? That's a scientific question. If the answer to that is yes, language exists. If the answer is no, then it's just like today's weather, just some odd collection of things going on. It's not an easy scientific question, but it's a scientific question. As for formal languages, did you bring up formal languages? Those are things we invent to have certain properties. The term language there is used just metaphorically. They don't have the properties of human language. In fact, they're invented not to have those properties. Actually, if you go back to, say, the time I was a student, 40s, 50s, the major, logicians and philosophers, people like, say, Tarski, Carnap, in fact, go back farther, Frege and others, they thought it was ridiculous to study human language because it's so imperfect. Why study something that imperfect? It's just a mess. Why not make up something that works perfectly, what they call formal language? Yeah, you can do that if you want, but that's like saying, why study the human visual system? I mean, I can make a camera, which is better, Okay, it's true, but not a scientific point.
Okay. Hello, Professor. Thank you for coming, and you still look fantastic, I must say. So. Everybody agrees. Everybody agrees. So, with language being so closely associated with power, do you agree or disagree with language being gender constructed? For example, the rule of his, her in a sentence rather than her, his. And is this based on a patriarchal culture circumstance, or is there some fundamental principle that can explain that?
It's an interesting fact, but I don't think it's really a fact about language. It's a fact about society. I mean, if we had a matrilineal society, it'd probably be the other way around. So it's a fact about the way language is used in particular social and cultural circumstances. Now, that's one of those many variable problems. At that point, you're studying a lot of different factors, not just whatever the language is, which is probably uniform for all humans, but what happens when this kind of biological instrument, if you like, is used under various conditions. And of course, it'll be used in different ways. And those are interesting questions, but not in a narrow sense linguistic questions. Those are sociocultural questions involving language, which is fine. Nothing wrong with those questions. They're just different ones.
Dr. Chomsky, given the ubiquitous of information and communication technology and how that seems to be so much a part of human development now, if you look at children and what they're exposed to, can you offer some of your speculations on how moving ahead generations that may impact language and thought?
It's a good question. Actually, there's been some study of it. So, children now are just immersed in complex video games, Twitter, text messaging. I mean, like my daughter, when she tries to communicate with her children, she can't use email anymore. That's too old-fashioned. For a while, she used to use, I don't know what, I think now they have maybe there's something beyond text messaging. You have to use something that's extremely fast and very short, and it doesn't go, it doesn't take more than 30 seconds to look at because there's too much other stuff going on. In fact, there was just a study that came out of some hospital, I forgot where, I think it was in Boston, was studying a new disease that's developing among teenage kids, almost all teenage girls, sleep deprivation. There's a very serious epidemic of sleep deprivation, and it turns out that it traces to the fact that these kids are holding their cell phones or whatever they use because they don't want to miss the possibility that at 3 a.m. some friend of theirs will say, I walked across the street, or something like that. And so you have to be awake to catch up with that. Now, these are pretty interesting facts. I'll tell you something that hasn't been studied, but may relate. I have a friend who was a bombing pilot during the Vietnam War. His missions were to bomb northern Laos. This is one of the major atrocity stories of the modern period. There was nothing in northern Laos. These were Stone Age communities, isolated Stone Age communities. People didn't even know they were in Laos. But they had a lot of extra planes with nothing to do with. After a bombing pause in North Vietnam, so they started bombing northern Laos. They probably wiped the place out. I mean, these people were living in caves for 2 years trying to survive. I've done a lot of work on it, interviewed refugees and stuff. Anyway, this guy, after it was done, like a number of people, he had second thoughts about, what the hell was I doing? And he's devoted the rest of his life to trying to do something to help those societies, what's left of them. One of the things he did, he got some philanthropist to agree to put up cell phone towers. These people are really living in the Stone Age, so they got cell phone towers. Now they have cell phones. And I asked him, what happens when you give them cell phones? He said, well, the first thing that happened is that the teenage girls started talking to their friends, and then it kind of spread, and some farmer would talk to some guy. It seems to be genetic, Yeah, I don't know. There are studies of what effect this will have, and nobody really knows.
Hi, I wanted to ask you about the proper relationship between language documentation and careful linguistic analysis, because if we're doing this kind of normal science mode of needing crucial experiments, it seems some of the crucial data might be disappearing fast.
Some of the crucial data?
Some of the crucial data. As endangered languages disappear, we might be losing access to some of the data that could inform our linguistic analyses. So what do you think the proper role of theoretical linguistics should be with respect to language documentation?
To respect to?
With respect to language documentation.
Language documentation?
Yeah, like the kind of old-fashioned linguistics that preceded generative grammar.
I mean, it's reciprocal. You can't, first of all, language documentation requires linguistic theory. You have to know what you're documenting, okay? So like when I was a student, the work that we did as students was language documentation. You take some Native American Indian language and try to get data from it. But the data you were looking for was dependent on what linguistic theory tells you to look for. There's nothing else you can do, All documentation is theory guided. Well, as theory changes, people ask to do different documentation. So field linguists today just look for totally different things than they looked for, say, 50 years ago. I mean, then you were looking for, phonetic contrasts and so on. Now you're looking for, are there transformational rules meeting certain island conditions? Okay, so sure, documentation is just data collection. And yeah, fields, of course, require data. But the kind of data you look for depends on what you think exists, what you think is important. And a lot of the data are just contrived. So these examples that I mentioned, say these ECP examples, you'll never get them in a corpus of data. I mean, almost inconceivable. But those are examples you construct on the basis of theoretical ideas which themselves are based in data, and then you see what happens in those cases. That's exactly like the normal sciences. Experiments, an experiment is very remote from anything that actually happens. You're interested in very exotic circumstances when you do an experiment. That's even true for Galileo. I mean, obviously for modern science. So I don't really think it's an issue. There's a constant interaction between data collection and theoretical development, and they influence each other.
Hello. David over here.
Straight to
Oh,
right over here, in the center.
Oh, okay. Oh, hi.
Hi.
Let's see.
Science looks for regularities in behavior, trying to induce, I guess, regularities of structure. And linguistic theory could be conceived of two ways. One, it is a way of analyzing the behavior, looking for regularities. So in that sense, it's just a mathematics. And you can have multiple linguistic theories, all of them being different ways to analyze the data. But linguistic theory could also be thought of as a cognitive linguistic theory, where it supposes real cognitive structures in the brain. My question is about computationalism. The problem with standard science is when different theories propose different structures, ultimately the only thing that can arbitrate is some sort of microscope, whether it's looking for germs or atoms or whatever. In computationalism, it doesn't look like we have a microscope. So the question I have is linguistic theory underdetermined by linguistic evidence?
Oh, sure, but every theory is. I mean, the same is true of quantum physics. It's vastly underdetermined by evidence. I mean, that's just the nature of empirical inquiry. It's underdetermined by evidence. That's why foundationalism was abandoned in the 17th century. It was recognized that you couldn't go any further than what David Hume called mitigated skepticism. You can make your best conjecture, you can try to improve it, but you can never establish it. There's no such thing as proof in the sciences. So all theory is underdetermined by evidence. In the particular case you're mentioning, it would be nice to have, important to have neurophysiological data, but it doesn't mean you can't do anything without it. You can take a look at alternative linguistic theories and ask how they deal with specific linguistic phenomena, like, say, these ECP examples. Do some of them explain it? Do some not explain it? That's perfectly good science. It'd be nice if you could find out what's going on in the brain, but that's pretty far off, even for insects. Yeah.
Professor Chomsky, you replied to an email I sent very recently about the Foucault debate.
About?
The Foucault debate from 1971, in which you mentioned, to my surprise, that there wasn't really a very pronounced disagreement between yourself and Michel Foucault. Would I understand?
Well, there were some disagreements.
But I'm wondering, in terms of the structuralist, post-structuralist relation, you were defending sort of the importance of affirming human nature and the need to find universal things that unify us.
Which he denies.
Yeah, and that's what that had always been my impression as well.
Well, he says he denies it, but it can't be true.
I agree. Yeah,
you can't deny it. You can't deny it because it's incoherent.
Yeah, that's
okay. So the people who most deny it are dedicated innate nativists. You have to be. There's nothing else possible. Otherwise, everything that happens is just kind of random.
Yep. Yeah, that's what I'd always thought.
I mean, it's an ideology, but when you take it apart, it can't exist.
Hello, Professor Noam Chomsky. How are you today? I just wanted to ask. Right now, I'm studying linguistics, and I can't find an answer to my question, and I look in the books, so I figured I'd trust your expertise on grammar and language. So I was wondering, do you have any recommendations for me to be able to talk to women better?
What?
Anything that could help him talk to women better.
About what?
Anything that could help him talk to women better.
They could help what?
Help him talk to women.
Oh, help talk to women better? That's like a lot of the emails I get. You'd be surprised. I got one a couple of days ago. Actually, my wife used to save these, but I got one a couple of days ago from some guy, teenage kid or maybe 20s or something, I guess, saying, I got a problem. I'm an anarchist, and I don't want to get a job in the capitalist system, but my girlfriend says she's going to throw me out unless I get a job. So what should I do? I'm the wrong person to ask. I don't know. I got out of that business 70 years ago.
Hello. I'm interested in you saying that meaning is primary, and I'm wondering what the implication is for creativity. Do you think that artistic expression, like music or painting, manifests from that primary source and bypasses language?
Does artistic creativity come from the same source as linguistic creativity?
Yeah, the primary source, but that it doesn't process through a linguistic through linguistic processing, it bypasses it.
This was discussed, nobody knows, but it was discussed in a lot in the 16th and 17th centuries, 18th century, early aesthetic theory, classical aesthetic theory and so on. So there was a conception, actually, as far as I know, it goes back to a 16th century Spanish philosopher, Juan Huarte was the first one to talk about it, then it was developed in later centuries, that he said there are three kinds of, let me see if I can remember it exactly, there are three kinds of intelligence. One is the intelligence of, brutes, animals. You just do things reflexively. The second level is normal human intelligence, which is manifested in the essentially creative use of language, the kind of thing we all do all the time. You make up new sentences, they express new thoughts, and so on and so forth. And then he said there's the third kind of creativity, which has actual aesthetic value. And that, he said, quoting from Plato, involves a mixture of madness. But whatever that is, it's beyond these two. And then there's a lot of discussion of that. Do they have the same roots? Nobody knows. I mean, there's nothing like artistic creativity to look at comparatively. I mean, you can't even find the second level of creativity in other organisms. And what's beyond that, who knows? Yeah. I mean, it is pretty striking if you look at the human archaeological record. Have you ever looked at the Lascaux paintings, for example? Well, they're pretty amazing. Actually, my wife and I saw them before they were closed off. By now you can't see them anymore, but we were able to get to them before the caves were closed. And you can understand how Picasso, for example, reacted. This is 40,000 years ago. And when Picasso saw them, he was stunned. He said they're the greatest modern artists, It sort of strikes you that way. So who knows where it came from.
We have time for 3 more questions.
Thank you. Hi. We're often told that apes do not have the articulatory apparatus to elicit speech, even if they were capable of it. And I'm wondering how we would go about, or basically why that's the case, or what the relevant criteria would be to adjudicate that question.
The question is dead. Really, a long time ago. I mean, look, there are plenty of humans who don't have the articulatory capacity for speech. They sign, In fact, deaf infants invent sign languages, and they turn out to be just like human languages. There are communities that are now discovered, like Nicaraguan had one, Yemen has one, where the people in recent years, in fact, just invented a sign language. They're deaf. I mean, there are people who learn language who are deaf-blind. Helen Keller, for example. The Helen Keller case is somebody who, she was deaf-blind from 19 months, and she learned language from a technique that was later independently invented. It's called Tadoma. Anne Sullivan, her teacher, figured it out herself, where the person learns language by just putting their hand on your face with the thumb on the vocal cords, and so you can tell if it's vibrating, and the fingers on the cheeks so you can tell what the articulatory apparatus is doing. And, well, Helen Keller was an extremely fluent speaker and writer. Actually, my wife worked on cases like that. At MIT, there was a project working on them. And these people gain incredible knowledge of language. There's an interesting fact, though, which has not been investigated, and luckily can't be investigated. There aren't any more cases. These are almost all cases of spinal meningitis, in which kids lost, and that's curable now, so you don't get any more cases, luckily. But they never were able to succeed with anyone who lost sight and hearing earlier than about 17 or 18 months. That's Helen Keller. She was 19 months. And what it strongly suggests is that these kids who are sitting there look like they're passive, like they're not doing anything. And maybe they're producing one word, or bye-bye or something. They're actually learning the whole language. Just inside, we can't test it, but that's what it looks like, and that these techniques are kind of eliciting it. But for apes, there's absolutely no reason why they couldn't learn. In fact, there were many years of efforts to try to teach apes sign language. The results are just zero. So it's like, in fact, the whole idea is, it's an illustration of the utter irrationality with which humans are studied. I mean, for example, suppose I were to submit a proposal to the National Science Foundation saying that I have a great idea about how to study bee communication. What I'll do is take a bunch of graduate students and train them to duplicate the waggle dance. It wouldn't be that hard. You run over to a flower and you run back and, you go like this and somebody else runs over. I mean, it's ludicrous. What would a bee scientist learn from the fact that graduate students can more or less duplicate it? I mean, absolutely nothing. So suppose you could get some poor ape to do something. It would mean absolutely nothing. It's just that we have this utterly irrational attitude towards ourselves, insisting somehow we must be just, grown-up apes or something. So therefore, let's see what apes can do and then we can do them. It just doesn't work like that. We're a different species, radically different.
I wanted to get back to the language of thought, which is very irritating from my point of view. The first products that we find that basically are also, indicating in the paleontology that there is this, new way of doing things and creativity are pictorials, right? So they are, some of those artifacts are, pictures. And so where I disagree with you is the interpretation of that evidence. Why wouldn't be able to have a thought of images, okay, which also displays the same properties like, introspection, and that has a more primitive basis on the neural system like dreaming. And instead we interpret that as the, indirectly by derivative, the generation, the creativity of the language system. Why is not the imagery system? I mean, the first products that we find are pictures and.
But actually, it's not the case. I mean, if you take a look at the archaeological evidence, like say Lascaux and these amazing paintings, they're much later. They're 30,000 years. The big burst of creative activity had to be before 50,000 years. There's a good reason for that. 50,000 years is when our ancestors left Africa. Okay, and we all have these capacities. So whatever was going on was long before Lascaux. And if you go back to that period, say, I said 75,000, that's a number somewhere in that range. The evidence that you get is not pictures. I mean, some of it is symbolic, but a lot of it is other things, like, say, recording of natural phenomena. I mean, you take a look at the people, anthropologists have worked out that if you look at the carvings on a bamboo stick, or whatever, that can't be bamboo, that'd be stone, I guess, so it remains. They reflect the phases of the moon, things like that. You get complex social structures.
They are pictorials. They are not language. They are not language manufacturers.
No, these are just evidence of creative activity.
And they are pictorial.
No,
right?
they're not pictorial. Well, I mean, they're in artifacts.
I have to disagree with you because
they have to be in artifacts, or you wouldn't find them.
I think that there are data, paleontological data that show that there are pictorials of 80,000 years ago in Africa. So
there's some, but most of the stuff is things like complex social organization, more complex tools. A lot of invention that was going on. There was just a lot of creative activity happening. Now, does that prove that? For a lot of that, it's hard to imagine it happening without language. This, incidentally, is not my thesis. Right. It's just the common assumption of paleoanthropologists.
But they can be wrong.
Sure, they could be wrong, but it's pretty hard to imagine why any of this would suddenly take place unless you all of a sudden had this means of thinking, even interacting once the secondary process takes place and so on. So sure, you can't nail it down. We don't have that kind of evidence. But there was a kind of a burst of complex creative activity. It's roughly in the period when it had to be the case that language emerged, because it can't have been after the departure from Africa. That's impossible. That could have been 50,000 years, some think maybe 100,000 years, but somewhere in that range. So they're all happening around the same time. What the source is, who knows? But if you can work out an idea of how a pictorial capacity could somehow lead to language, well, it would be interesting. I don't think anyone's tried to do it.
Last question over here.
Hi, Professor Chomsky, I want to thank you for your talk. I was just wondering how much of an effect do you think behaviorism has had on the continued question of the existence of language?
The
continued question about whether or not language exists.
Oh,
and
I understand. It had an overwhelming impact.
Yes.
The behaviorism can't die. It doesn't matter how often it's refuted and how fully it's refuted. It comes right back to life. It's kind of like genetic somehow. Actually, I was taught just in Toronto. I was in Toronto a couple of days ago. I was talking to a very outstanding neurolinguist who works on these, done a lot of the work on these topics, and she was telling me, not as a joke, about what happens in her introductory courses. She teaches language acquisition. In her introductory language acquisition courses, the first day, she asks kids to say, how's language acquired? She says about 100% say reinforcement and association. I mean, it's it's been refuted so overwhelmingly that you don't know what to say about it. But you're absolutely right. It keeps coming back, and it's at the core of these computational cognitive science approaches. They don't call it behaviorism anymore, but it's sort of the same idea. Actually, behaviorism, in any serious sense, collapsed in the early 60s just for internal reasons. I mean, there were interesting things that happened that essentially wiped it out. So, for example, are you a psychologist? Oh, you know this stuff. Well, if those of you are psychologists ought to know that a lot of this stuff's been forgotten, because people forget everything that isn't on the internet. But it's back around early 60s, there was a very interesting paper in Psych Review, the main psychological journal, by Keller and Nancy Breland. They're Skinner's two main students, the most loyal Orthodox students. They assumed, like everybody, that the game's all over. There's no point studying anything anymore. Everything's answered. So they went off into animal training. And in fact, they're the ones who trained all the famous animals, like, Flipper the dolphin and all the things that my kids watched. I don't know what you watch, but, and they discovered something. They discovered that when they were training an animal, they got the expected results up to a certain point, and then the results started to deteriorate. So, for example, I remember one case, they were training a pig to pick up a coin and put it in a mail slot and, get whatever pigs like, reinforced by some food. And according to the story, the pig is supposed to improve its behavior. Don't do any other things, just go more and more right to the coin, put it right in, don't waste any time, you get reinforced. And that worked up to a point. But then after that point, it turned out that the pig started rooting at the coin and delaying the reinforcement and would continue to do it up to the point where it starved. Well, what was happening is what they called instinctual drift. Pigs root, that's what they are. And they were interpreting this whole coin business, some crazy thing that the experimenter made up, as just some funny kind of rooting. And they then, over time, went back to their rooting. Well, then they started looking at all the experiments in the lab. It turned out the experiments are always terminated when this begins to happen. So you get a smooth learning curve, and then things start to go haywire, so you stop the experiment. And say the Skinner experiments were pigeons pecking. Well, it turns out there's two kinds of pecking. Pigeons peck for corn, and they also peck for water. And they look kind of alike, but they're different kinds of pecking. And the things that the pigeons were able to be trained on actually were adaptations of one or the other of these kinds of pecking. You tried to get the pigeons to do something else, you get nowhere. But if you kind of modify their instinctive behavior slightly, you can sort of fool yourself into thinking you're getting results. But before too long, the animal takes over and it's doing what it was doing. So it kind of wiped out the whole field. Later work in the mid-60s already began to discover that, I mean, I remember this happening. I was involved in it. But I remember I once gave a talk at the University of Illinois or somewhere. It was a strict behaviorist department. And, you know, I talked kind of like this. You know, it's 50 years ago, so different, but same idea, saying that you can't get anywhere with conditioning and reinforcement for the human behavior. So one guy got up, a very good behavioral animal psychologist, and said, how do you know it works for animals? So I said, I don't know. You guys say it works for animals, so I suppose you're right. And his name was Bill Brewer. And he got interested, and he started redoing the animal experiments. And he started publishing some papers, and it turned out that the animals are getting reinforced only when they're aware of what's happening. If you set up the experiment, you can do some sophisticated experiments that distinguish cases where the animal doesn't know what's going on, and then it doesn't get any reinforcement, and reinforcement doesn't do anything. And other cases where the animal sort of sees what's going on, it gets reinforced. So his conclusion, and others too, was this is just information transmission. You know, it's a reinforcement experiments are an odd way of providing the animal with information. I mean, you can't tell them peck when I tell you to, so you do it this other way. And there's more work that did that. But by the in more recent times, it's not even evident that conditioning exists. There is work, again, Randy Gallistel and others who've argued that it's all an artifact. It's just various ways of estimating values of variables, and the whole thing kind of collapses. But it doesn't matter. You're exactly right. No matter how much it's refuted, it's right back the next day.
Thank you.
Mm-hmm.